in PyCharm, you are using not cluster. You are just using the dependency root.
Uh,
PySpark library dependency. You are running
can
it.
you send me a link?
Yeah, this is very. You have I just
Can you put it in the chart? Okay.
the classroom also I will add it. So once you take this link, okay, and you open your PyCharm, in PyCharm you download, install the community version. Otherwise,
Uh-huh.
without community
Yeah,
version.
yes, yeah. Last time, yeah. I went to community service only.
So once you start your PyCharm, so you have to do the setup for the PySpark. So once this PyCharm, here
Uh-huh.
we have to go to settings and just we have to for any okay first we import the project. For every project
Okay.
we have to do that setting for the running a PySpark code. So we have to new project. Get from the version control. So if you are getting
Version cut. Okay.
get from the version control, so here you just put your and
Okay.
will be in your workspace. You can
Mm-hmm.
see the same project. Then you can so this is already exists. Mine is already imported.
Okay.
So when you
Okay,
close,
I'll do.
so here you have to do first project and where you want to open it. If you do here in this window, so this
Uh-huh.
window is replaced with the
Oh,
this
okay,
window
I'll do.
and here initially here it will be showing error because I have to I have not set the library so well, whatever Python will and here rather than going this way we go to settings project structure and here we go project structure and here we have to do add content to add content to I have to go to my Spark installation directory
Okay.
and there is the Python and here is the list. These are the two jars. Like one is a chip. These are the two chips that we have. Right. Then now I want to run any file. So, so this is like a data is there and we have a create data frame data 2ds like giving column names to the data and I'm just selecting the date column.
Okay.
So now it's giving some errors on the library. Okay, so it is giving the issue on the creating a data frame. Like here, Spark. Version related, what is Spark version? Python version. Okay, so this not, this is showing gray. So still it is not importing the pi star. This is my previous problem. Okay. So what is the difference? So here I'm giving the same thing. So one thing. You are getting also the same issue?
Yes,
The same one.
yeah, I'm checking.
Something is the same. Because the Python version of the Spark version should be compatible also. Change my Python version. So this is the Python setup. So let me go to this is my local. This is Python 3.8. You can put this is a Python 3.8. I tried this one to run the same program. I change it here, the Python interceptor. So 3.8, I change it to Python. So just I need to change the pandas one we have to install pandas. That's also in the time. Also. Okay, so if you use the 3.8, because don't use a higher version, because whatever my Spark version that is not compatible with the. So now it's a different error, but my that error is not coming. This is the other. Like I have a data frame I'm creating with the schema, data frame dot select, and the department df dot select department name dot select. So I'm just printing as the RDD. So this is the schema. This one is the schema. So data frame schema, I'm showing here print schema. Now it's a You can still here department dot df dot show when we are doing, then it is network reason Windows has a lot of issues because one to be so this df dot show is giving error. And this one is saying job is aborted from Python what you failed to connect. This particular error, so when it is going to show the data frame, that time it is error. Otherwise, print schema is showing. So while data frame is how about it? Mm, it's quite hmm. Something like whenever we are doing the show, like when we are calling action. So was not Okay, so 3.10 I installed. Just giving error. I need to. Five. Okay, try this one in the one two. Okay, one two will not be complete. So here you have to start from the calendar. You have to go to my channel. So you start with the Python first. So before that, you install the Python.
Oh, I don't have any Git. I don't have Git software.
It you can do.
Yeah, I can. Yeah, just I will install.
So this Python is the 3.8.3. Actually, this issue will not come in the Windows. The problem is The Python, if you are executing separately, it will work fine. You are doing the PySpark using Python. So if you're seeing there, the Python zip file is giving issue, the library serialization problem, and then we fix it that, so it's
Okay.
giving. So if you start here your Python, so just make sure like you have already installed Python in your, and then go here. The same like here we can import target. Okay, I will go first. This is the setup thing. Okay, so what is the Spark fundamentals? Okay, so when we start the Spark, right? So Spark, there are many versions. Right? So we are going to use the Spark 3.x version. Okay, and before this 3.x, the Spark, the earlier version is 1.6. That is the old. The starting version is a 1.0 or 1.2. That version came, but this 1.6 version in the 2016 around. Okay, the time this version was there. Then Spark 2.x, that is a major release change in the Spark 1.x to 2.x. So 2.1, 2.2, 2.3, like that version came. Okay, 2.4 was a very stable version. Okay, of the Spark. Okay, and that was till 2020. Okay, this version, and then Spark 3, the 3.x release is going on. So if you've seen in the these days, so Spark 3.0, 3.1, 3.2, 3.3, and even if you download the Spark you download and you start the Spark shell or PySpark shell. So if you go to the Spark download, then go to the Apache or the website. So this is 3.50 is the latest release in the September. On November 30, this is the, so this is 3. These are the stable release, like version they have given 3.5.0, but the stable version is this December 2020. This one 3.34 you can use, or even 3.4.2 you can. Okay, so these version you can take it and you can download the tar file and set the home path, and then you can start the PySpark shell. Okay, so if you're using so 3.3 or 3.4 version, you can use 3.4.6. Okay, but the Scala compatibility you have to see, because Spark is running along with Scala. So Spark is basically on top of the Scala, because Spark is written in the Scala. Spark is written in Scala. So Scala version is very important. Which is Scala version you are using? So Spark written in Scala. So Scala is a 2.12 or 2.30. They are having a 2.12 and 13. So if you use a 2.12, Spark with a Scala 2.12, so if you are going to do integration with the Mongo, Cassandra, so you can do it. But 2.13 will be uncompatible version. Okay. So if you download, just try it. I think here later Scala 2.13, or this one you can take it. Okay. So Spark 3 is using. So you take it once Scala, it will be Spark Scala or PySpark. Okay. So in the, so once we start the Spark, okay, so first thing is the Spark is the different modules are there. So Spark core. So Spark core is a core module, that is the basic module that has the transformations and actions. There are the different transformations are there. So we have to learn all those transformations and actions. The transformation is basically converting data in one form to another form. That is transformation. Transformation is basically conversion of this conversion. So Spark is having three data structures. Okay. what are the three data structure in the Spark? So three data structure in the Spark: RDD, data frame. So RDD is the first data structure. Second one is the data frame on top of the RDD, and third one is the data set. So we can say the data set is an extension of RDD and data frame. And RDD is a basic fundamental data structure, like it is an immutable collection of the data, immutable collection of data, which is spread across workers executors. So in Spark, there is a concept of master server and executors, worker executors. So every workers having the executors, those are performing tasks and getting results in executors. Okay. And finally giving to the driver, executor and return back to driver, and driver is showing to the client. So here is three different types of cluster manager comes in picture. Okay. So data frame is basically refined from the RDD. It is a tabular representation of the data. So RDD is basically used for unstructured data. It is used for unstructured data. Okay. Unstructured data means not audio, video. It's a text file data which is no fixed column. There is no fixed schema. If I say this is unstructured data, because this text file has no fixed number of columns, because here are the 3 columns, here are the 4 columns, here are the 5 columns, here are the 6 columns. So this is a different number of columns. Okay. So this type of data is called unstructured data, text format unstructured data. So RDD is basically do the transformation row by row, like this, row 1, row 2, row, like this. And data frame is a tabular representation of the data. The tabular data is in the form of rows and columns. We know, right, tables in the SQL database. The tables, like, right, tables in SQL databases. So in SQL databases, we have tables, right? So it is a tabular representation of the data. So data frame is doing the operation as a columnar form. Like if I say CSV file, if I'm reading a CSV file, JSON file, XML file, Parquet, ORC, Avro, okay, Avro, or fixed width file. I showed the example in Hive, fixed width file, like there is no delimited character, fixed width file, or some example like SQL databases, we are getting the data, okay, or no SQL databases, we are taking the data, okay, or we are taking some cloud SQL data warehouse like Snowflake, or we are taking the data from the S3 file system, okay, or any other cloud file system. So everywhere you are taking data, that data will come as a data frame. Okay, so data will be data frame. Because these are all formats, data will be data frame. Okay, because all these formats are the schema associated data. If I say CSV, right, so there is a fixed number of columns are there. JSON is a key colon value is there. XML is a node are there. Parquet, all are having attached schema. SQL database schema is there. No SQL schema. Snowflake is also schema. So everything is having the schema attached. Okay. So that is the reason, or fixed column. If schema means CSV, there is no schema, but fixed number of columns are there. Predefined column, header is there. So data will be as a data frame. Okay. And this data is a data frame. Basically, we read by different methods in the Spark. So if my CSV file is there, I will read spark.read.csv. If my file is a JSON file, so I have a spark.read.json. So Spark has given predefined methods. We can read that particular format of data. If I'm reading a Parquet file, spark.read.parquet. If I'm reading a XML file, spark.read.xml. If I'm reading a SQL DB data, the SQL DB data is a JDBC format, spark.read.format, and bracket double quote JDBC, and then you will load the data, dot load. Okay. So these are the VR data frame, right? Basically, the data is a tabular representation, and we are working on a column. Here in RDD, in the row by row, we are performing the operation. The operations are same. When I will be talking about the transformations and actions, these are common to both transformation and action, which are common to all three data sets. So this transformation and actions, these are all common to the RDD data frame and data set. The data set is further one more layer extension is there, one more extension of data frame, extension of data frame. It is a strictly typed API, strictly typed, okay, type based, okay, like entity based, type based or entity based. Okay. Entity based means like if I have an employee data set, so I will be having an employee as a data set element. So it will be a completely strict type of data type of the employee fields. Okay, and it is using one more advantage in the data set is there using encoders. Encodings are available, encoders. That is not there in the RDD and data frame. And data frame is using optimization through the Catalyst optimizer. So Catalyst optimizer, Catalyst optimizer is a optimizer, right, which is optimizing your query, right, SQL queries, right, in the data frame queries. Okay, so either you can use a data frame API or Spark SQL. Okay, so anything you are using, the Catalyst optimizer is helping to optimize queries. Okay, so that is by default Catalyst optimizer is for the data frame. RDD there is no optimizer. RDD you have to write manual way to optimize your own, right? It will not do automatically, but dataset has tungsten. So tungsten is the optimizer in dataset. Okay. So these are the differences, and it is using encoder and typely safe, okay, strict type and type safe. Okay, type safe also. Okay. So this data set is the extension of the RDD and data frame. It's a superset. So data set is superset of RDD and data frame. So I say, like if I have RDD and data frame, so I have both the features. I have both the features of RDD and data frame in the data set. Okay, but mostly we perform data frame because data frame is much easier, like tabular representation of the data. So we go for data frame, data frame API. Okay, and in the PySpark, data set is not directly supported. Okay? Because Spark Scala is supported all three data structures, but PySpark is not directly. Indirectly, we can work with the data set. So you will find one difference when you are working with the PySpark. So there are the multiple flavors in the Spark. So Spark Java, Spark Scala, Spark Python, okay, and Spark R we can use. So for R programming language, we can use Spark R APIs, Spark Python API, Spark Scala. But when it will be execution point of view, everything is converted into the Scala. Okay, because the inbuilt APIs are there in the Scala. Okay? But user interface, like okay, you are writing your program in Python, you are writing your program in Java, your program in R or Scala, but which one is the more faster? The Scala is more faster. Because in case of Scala, it will be not converting, right? Because here it is more faster. So generally, for better performance or faster execution purpose, the Spark Scala applications are used. But if any machine learning library, data science library, if I want to use, then PySpark is a good choice. So PySpark is a good choice, is a choice for data science and machine learning, because Python is very good supporting machine learning libraries, right, in the Python. So we can use the price for the data science and machine learning. Or even Spark R also we can use because R is also a good programming. So transformation is basically the conversion of data one form to another form. So there are the various transformations functions are there. So map is a one, flat map, filter, join, group by key, reduce by key, right? Aggregation, basically group by key, reduce by key, the aggregations. And union is there, right? Like how to combine the data sets, right? So two data frames are there. So these are the common transformations. The same transformation you can use on the RDD data frame and data set. So these are the transformations are common, right? Any data structure you can apply your transformation. But when we call it action, action is basically giving you the end result. It is basically applying your action and you are giving a final result, right? If I say count is a action because it is giving you the final value. Like you say you have 5 rows of the data. So what will be the count will come? 5 will. If I'm using collect, collect is also action. This is for RDT. If I'm using count, collect, take. So if I say take 2, the 2 record it will take. Or I have a luck or for further other actions are for each. For each is the action for printing the data, right? I want to print the data. So for each I can iterate. I can iterate the data. So for each is there. So action is basically performing and it will giving a final result. Further, you cannot do any transformation. So one transformation you can apply another transformation. Suppose I read a data, I read a file, I got a RDD, and then I converted data frame. And another scenario is you are reading a file, but here you are reading a text file. Suppose you are reading a text file, and you are converting into RDD, then RDD with data frame, and then you are applying the transformation like map, then you are applying flat map. So there are different transformations you are applying, and finally you are applying the action. But suppose you are reading a CSV file. The CSV file, you don't need to get RDD. You will get a data frame. And this data frame, you can do the same transformations. You can apply map, flat map, filter. Okay. Filter you can do. The filter transformation is filtering the data. Suppose I say I have a data like ID, name, age, city, and I have some data. And I want to find a particular city data. Or I say like age is greater than some value I want to find. So I can do filter. So how to write a filter? So I want to write a filter. So first I have a data frame. So I say data frame dot filter. And then you will say, okay, I want to apply the transformation on age. So I will say age is greater than 30. So which record will come? It will give you the second record. Then I can do the show. The show is also action. Show is the action. Is an action. For data frame is a show action, which is showing a data in a tabular form. Okay. So one record will be showing in tabular form. Okay. So you will get the data once after you apply the filter. Okay. So this way we can use map, flat map filter. So you'll see all these are the transformations, but you are reading a file, CSV file, JSON file, XML file. So this will give you directly data frame. Okay. So you can see the examples. Okay, so there are some examples you can find and you can prepare the data. You can prepare the small data and then you can do the transformation. You can see that. data frame one, you can find the example here. The data frame one, flat map example is there. Okay, so there are the different. Reading a file, or maybe so this is a hard coded value one. Okay, so this is hard coded value. But if you are reading a file, so you can some CSV file or JSON file if I'm reading, that file is. So this example is the hard coded data is there. So I have a data in a, like I'm preparing the data as a list. Okay, and list is a tuple. You see. Okay, so this tuple data I'm mapping in the column schema, right? I'm saying first column is the name column, and here I'm just giving fields. Okay, so when you are how to search in this control shift R. When you do control shift R, you can search. Same like when the IntelliJ. So IntelliJ also the same thing. So CSV file examples you can see. I'm searching CSV, right? So this is the zip code CSV it is reading, right? These are the CSV examples. So this CSV file, but this is not a correct drive, right? Because my file is okay, my file is in the SRC package. So I don't need to give this because I'm not running in the Windows, right? So my file is not in the some C drive. Okay? My file is in the SRC folder. So I should give the folder. Okay, here is no SRC. So my project folder is there. So your file is where this zip code CSV. So some resources folder, you have the file. Your PySpark example, and there is these files. So zip code.csv file. Okay, but you have configured your chip, right, and this settings, right, project structure, so you will not get that error. So Python error you were getting there. The data frame dot to. Are you able to see, right? So this way we will get a data frame with the 3 columns. The name column has the first name, last name, middle name, right? All 3 columns. So this is an array type value. Okay. If you see the language is the array type. You see, square bracket is there. It's the array type. Okay. So we can use the explode function on this, and we can make it a separate code. So there is a one example of the explode. Okay. So these examples, right, I will show you, but I'm just showing you, right, if you want to practice, you can use explode function is the same example, but with the explode. If you see df dot name is language mark. So this is a different example, but the data set is same. If you see here explode, so here they are using explode function. So just whatever your knowledge, known languages, right? So we use the explode function. So it will be convert, in Hive we did the explode, right? So basically the explode is converting your arrays value to the separate rows. So you will get, if you run this program, you will see data set is same. So same data set. Array map or C, right? Code will be exploding the values into the multiple rows. You can try more transformations like map, flat map. Just take an idea, right? What type of transformations? Okay, like distinct is the one function is there, that is a transformation. So it will make a column value distinct. Okay, date functions also there, date difference. So if you see these examples, you can. These are the functions, not the transformations are like when you apply on the data frame, that is transformation. Like select, this is a transformation, like you are selecting the columns. Okay, so directly you are doing something on the data frame, that is your transformation. And function says in the select, you are saying, okay, this particular column I want to apply date difference function or current date function I want to apply. Okay, so that is your function, right? So function you can use in the with column, right? Okay, some new column you are creating using the with column. So you are creating a new column and you are defining. Okay, so something is speed is slow, otherwise this result will be coming faster. Okay, so same program we can run on the cluster. Like we have this py file, I can execute on the my Spark cluster. There I can do the Spark submit job on this py file. So three ways you can run the program. One is on the PySpark shell you can run the same code, or you can run in the IDE the same code, or the same code you can run on the PySpark submit. Okay. So these are the three, and now you will see the data. So now it is exploded. You see the languages are exploded. Okay. So Java, Scala, Spark is coming with the same person. So it is exploded in a different rows. Okay. Okay, so tomorrow I connect and start from the basic transformation. So you go through it, right? Different transformations. Okay. And you connect. Okay, thank you.